Probability. I'm even sighing as I say it. Like so many of you, I am relieved to move on from the linear equations unit that was computationally heavy, that was demanding, that was taxing. And let's get to some water in the desert with this probability unit. There's a reason that I align this here with my curriculum. I know that after what we just did, you're going to want to break. You're going to want to get something else in your system. I am so happy to have integrated math as what I teach. An entire year of algebra is too much algebra. And then an entire year of geometry, it's too much geometry. When are you going to fit in the other stuff? If geometry connects to algebra, you might have to wait a year, 2 years until you get that. And then all of a sudden you're in algebra 2. It's been a year and 2 summers since you've been in algebra. That whole system, I threw it out when I got to Oxley. I said, you know what? Let's not do that. Let's just have a kind of system where we can teach different topics, almost like English teachers teach different books. And whenever students come in or leave, they can just jump right in with the next topic. I think you're going to enjoy this unit a lot, especially relative to the last one. And it's your reward for getting through it. And if you still have to go backwards and do some of those old assignments, well, you'll get those done in time. But for now, let's jump into probability. And one thing I'm going to ask of you is that on the right side, in addition, let's start on number 1. In addition to having your Desmos calculator, you're going to want to have your simplifying fraction calculator, which thanks to the people again at Calculator Soup for providing this one. You can utilize that. Maybe you can go on Google and find another one. Calculator Soup's the one that I use. Also notice that it says cannot redo individual questions. That's because in this greatest gift of a unit, this first assignment is an even further gift because it has a lot of problems that are similar from me to you. I'm just going to be straight up with you. And if you pay attention and follow along, you're going to get these right. But if you find that you miss one still, here's what you do. You scroll down, you hit finish attempt. When you hit finish attempt, it's going to give you mostly blank stuff. You submit all anyway. You're going to get a grade. Then you just hit right back to where it says probability. And you just redo it. And you're back at number 1. Square one, as they will. All right, let's go over this. It says find the probability for the roll of a number cube. Write your answer as a simplified fraction. The first thing about probability to know is that it is the most applicable mathematics you will learn in school. Anytime you play any game, you're doing probability. Anytime you really make any decision, you're doing some aspect of probability. You're chancing something. Hey, if I hit that snooze button, am I going to have enough time to shower to get to school? Hey, if I go a little over the speed limit, am I going to get caught and get a ticket? If I maybe stay up sending messages to friends, or I'm trying to date somebody and this last message I send, is that going to work in my favor or not? There are lots of ways of risking things in life, all of which have some sort of probability, and they will for the rest of your life. You won't always be doing a system of equations. You won't be doing algebra with substitution and elimination, but you will be, man, can I get that supersized meal today, and is that going to affect my health or not? Probability constantly, every single day. Probability, in terms of theoretical mathematics, is really about 2 things. The first is it's about fractions. So we're going to have reduced fractions almost in all of our problems, where on top you have the number of things, let's say, we care about. Now that's not in the world. That's obviously so many things you care about. Friends, family, food, other things. No, it just means for our problem. Like how many of the things that we care about that we're asking for. And then on the bottom, we've got the total. Total number of things. This is so eloquent. Hopefully my English teacher never sees this, all the things I just wrote in here. So like number 1 asks about a number cube. A number cube is a fancy way of saying a die. Lots of people say dice. That's multiple die. Just one of them is a die. Well, one of them has 6 sides, And if we want to know the probability of getting just one of those numbers, then we only care about just one of those numbers. If we care about more than one, then we change the numerator to reflect that number. So I'm going to close this in 3, 2, 1. I am closing it now. And you see right off the bat that that's exactly what we're doing with number 1. P6, this P parentheses 6 that's right here, that means what's the probability that you roll a 6? So for you it might say P1, P2, some other number. Well, there's still just 6 sides on a die, and there's still only one of each number. So it's going to be 1 out of 6. And like I said at the beginning, if you follow along, hey, it's 1 out of 6. Go for it. My gift to you to start this unit. Now we have a number cube again, but the probability of rolling a 1, 2, or 4. Now we have 3 choices out of still 6 options. And the simplifying fraction calculator, look at that improper fraction I did long ago. 3 out of 6. You should probably know this, but even if you don't, hey, it's 1/2. You reduce the numerator and the denominator by 3 and get a half. We always, 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 as it says in this problem, want to put our answer in as a simplified fraction. So 3 out of 6 would not work. You would not get that correct. You'd have to redo the whole assignment. If you're out there and that's you, and you're cursing to yourself over it, I'm sorry. Now you know. It's a tough lesson to learn. Find the probability of the roll of a number cube. Write your answer as simplified fraction once again. P even number. Okay, let's review even and odd numbers. It's much easier for me to put a number down like 10 and say, is that even or odd? People go, oh, it's even. And then I say, why? Let me review. So we've got our odd numbers here. And 7, 9. And we've got our even numbers here. One of the things you learn in college when you're a math major is sort of how to prove things. And that includes with even and odd numbers. And the formal definition of an even number is such that if you divide it by 2, your remainder is 0. You have no remainder. It divides evenly into 2. Whereas if it's an odd number, you're going to have a remainder of 1. It's not going to evenly divide into 2. I guess this is technically 1 remainder 1, right? Old 6th grade. So on a die, since it goes from 1 through 6, I've got 3 odd numbers, and I've also got 3 even numbers. So once again, whether it says odd or even, I'm going to get 3 out of 6, and once again, that still reduces to 1/2, so that's what we want to put in, 1/2. And you've learned some odd and even, say even? Even mini lesson here. All right, let's talk cards. I love cards. I love so many games that have cards. The game has 30 cards numbered 1 through 30. The cards are shuffled. 1 card's picked at random. Find the probability for picking the card. Write your answer as simplified fraction. Okay, if we have an even number of numbers like we do on a die or like we do on these cards, like I have 30, I'm sure it's out there somewhere you have another even number. That means 1, 3, 5, 7, 9, all the way out to 29. 1/2 of them are going to be odd again, and the other half are even. Sometimes people call this the 1/2 assignment because so many of the answers, maybe about 1/2 of them, are a half. And that includes this problem. All right. Moving on to 5. A game has 50 cards numbered 1 through 50. The cards are shuffled. 1 card is picked at random. Find the probability for picking the card. Write your answer as a simplified fraction. P54. Well, if I had cards numbered 1 through 50, I could try as often as I want, as many times as I want, for as long as I wanted. I would never, ever, ever get a 54 because I just had up through 50. And sometimes students get pissed. They go, Dylan, this is a stupid problem. What do you mean 54? I said, yeah, what do you mean 54? What number would that be? Well, you get no chance, none. Like, exactly. What number is none? 0. And 0 reduces, it's already 0. If I could put 0 out of 54, don't do that, because watch. If you do 0 out of 54, you're not going to get it right. It's going to say, write your answer as a simplified fraction. The correct answer is 0. So just put 0. That reduces. And this will be a rare time where I'm not going to go back and redo the whole assignment. I'm just going to leave that there, this red mark in an otherwise green world. All right. Find the probability for choosing the letter at random from the word proportion. Let's count how many letters are in the word proportion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 letters. The probability of getting an R. So come over here and write 10. And then how many letters do you have on top? So for R's, I've got, it's like the pirate, R's. 1, 2. I've got 2 R's. So 2 out of 10 reduces to 1/5. If you have a different number of letters for the letter you have, put that one instead. This might be one of the few that we don't have the exact same problem. Vowels. Let's review vowels. A, E, I. Yep, got one of those. O, got 3 of those. U, sometimes Y. Don't even have any Y's here. So we have a total of 4 vowels, 3 O's and an I. And 4 out of 10. That reduces to 2/5. Number 8 of our word proportion. Now, what's the probability of drawing the letter B? Well, just like 54 out of 50 cards, there are 0 possibilities, and I am not missing another one just to show you that it doesn't work. 0 again. 0 straight up. All right, spinner. Normally you would have a lovely arrow that would point out that you would spin. It would land on something, but for simplification of this little chart here, we left that out. Notice it's numbered 1 through 8. Every single time I do this problem, I always ask people, hey, how many are here? And they always count 1, 2, 3. And notice you don't have to do that. They're numbered. It goes up through 8. There are 8 choices. P blue means what's the probability if I spin it, I land on blue? Well, there are 1, 2, 3, 4 blue out of 8. This isn't, again, one that you should probably know in your head, but let's just show it. 4 out of 8 reduces to 1/2, because 4 is 1/2 of 8. So it's a simplified fraction, that's 1/2. Well, what is that as a decimal? Again, that's something you should probably know, but if you don't, you do 1 divided by 2 in your Desmos calculator. For the first, is that the first time we used it the whole time? I think it is. 0.5, don't even need the 0 in front. And as a percent, just put in the number, don't put the percent sign. You take whatever decimal you have, and you multiply it by 100, because percent's always out of 100. So 1/2 of 100% is 50. And again, you don't need the percent sign. And if you liked that, you're going to love the next one, because guess what? We've returned to our odd and even, where we have an even number of things. We had 6 for a die. We had 30 cards. Now we have 8 spaces for our spinner. And so just like before, just like including 9, 1/2 of these problems, I believe, are exactly 1/2, which means we can copy from ourselves over here. The decimal's 0.5. The percent's 50. And we are done. For one of, if not the only times we will ever do these assignments together, I am not going to get 100. I'm going to get a 90. I would have to redo the whole thing to get 100, and I would if I was a student. I would have just redid it before I even did number 6. Well, in the first place, I wouldn't have missed it. I told you I knew it was 0, but there you go. Soak it in. The rare 90 from your teacher, Dylan. We're all human, even me, even though I missed that one on purpose. Okay. Much love, best wishes to you, and welcome to the probability unit. It's good to have you here. Soak it in. I'll see you back next time. Bye-bye.